Hi everyone, welcome to EFS, and this is project number 1, and in this video we are going to make a small IoT project. So we're going to take a DHT sensor, fetch temperature and humidity from it, and then send it to our own created mobile app. So we will be using an MQTT protocol, and we'll be using a free MQTT server which is HiveMQ. Okay, so let's get into it. So before starting the project, let's just understand what MQTT actually is. MQTT stands for Message Queuing Telemetry Transport. It is a lightweight messaging transport that is especially designed for IoT devices. Okay, you can just call it as a WhatsApp of IoT devices. Okay, so in this, it actually works on a model called publisher and subscription, which is like a request and response model of web, but it's very different from that. Okay, let's just understand what is this publish and subscription actually means. So let's just say I have two clients. Okay, in our case, a first client is NodeMCU, okay, which reads the DHT sensors temperature and humidity and sends it over to the MQTT server. And the second client will be the mobile app. Okay, so this one's also a client. So this one receives the data. And then we have the server, HiveMQ. So in this model, in MQTT, we call this as a broker. Okay, we can call it a server as well, but generally we call them as broker. So what is a publish and subscription model? So when some client sends a data, okay, it's called publishing. Now, it's called a publish, and the format is called publishing. And if a client receives the data, then he is called a subscriber. Okay, now there may be a question like, how does the client which sends the data and the client which receives the data make sure that they receive the same exact data? So for that purpose, we have something called topic. Okay, so now let's say our topic is EFS. So the client, the NodeMCU client, which is a publisher, has to send the data with the topic EFS. Oh, the spelling is wrong, I'm sorry. TOPIC. And the subscriber, which is receiving data, should subscribe with the topic EFS only. Only at that point there will be an exchange of data. Along with that, in MQTT we have three reliabilities, like quality of services, which tells us how much a specific message is reliable. Okay, so let's just go into what are those. So we have three quality of services: QoS 0, which is like mostly once. So you can call this as mostly once. Most of the libraries, when you say QoS dot, you will be getting like this: mostly once, at least once, exactly once. Okay, so QoS 0 is mostly once. So what does it mean? So this means that the client, when it sends the data, when the quality of service is set as mostly once, it's not going to care whether the message has been sent to the server or the message was received by the subscriber. It doesn't matter. So there is always a chance of loss of messages, but this is the fastest one. Then we have QoS1, which is at least once. So what does this mean? That the client which sends the data waits for an acknowledgement from the subscriber that he has received the data. If it doesn't receive that acknowledgement within a period of time, the client, the publisher, will send the data one more time to the subscriber. So the problem here is that the subscriber may receive duplicate data. And then we have finally QoS2, which is exactly once. So, I mean, you could have understand already. So exactly once it makes sure that the client has received the data, and at the same time it doesn't send any kind of duplicates data. I mean, it may send only if there is no, like there is a specific pattern, there is a handshaking model. If that handshaking model fails, only at that point it's going to send the data again. Okay, so this is pretty much how MQTT protocol works. And now let's just get into the coding part. So yeah, this is a basic connection between the NodeMCU and the DHT sensor. So the red line is the power line, the black line is the ground line, and the yellow line is the data line. So we will be adding a pull-up resistor to it as per the schematic that was given in the data sheet. Okay, so if you have purchased a module like mine, so you will be having three outputs. So this is the module that I have purchased from the Amazon itself. So you will be having three pins. So the first one is the VCC pin. Let me zoom in a bit. Yeah, so the first pin is the VCC, the red one, the data, the yellow, and the GND, the black. Okay, so how we're gonna connect them, it should be something like this. So the red one, the connections are pretty much as per the schematic. The red one goes to the 3.3 pin, the black one goes to the GND pin, and the yellow one goes to the D4 pin. Okay, so I'm going to use the D4 to send the data to NodeMCU. Okay, so before getting into the code, we have to download a library called MarkRuiz. Okay, so it was given by MarkRuiz. It's an Arduino DHT library. So this library gives us a direct functions through which we can extract temperature and humidity directly. Okay, we don't need to write any kind of calculations. There are many more other libraries, but I prefer this one. You can use anything. So how we're gonna use this one, we're just gonna we're gonna just download it as zip. Okay, then we're gonna switch to our code. Okay, in that we'll go to sketch, include libraries, add.zip libraries, and then we're gonna just go to download and select the library. Once you have selected, the library will automatically be included in your library set. Okay, so now let's just get into the code. So first we have three primary steps in the from coming to the coding perspective. So we have three primary steps. So the first one is connecting the DHT sensor and extracting the data. The second one is connecting to Wi-Fi, and the third and the final step is connecting to an MQTT server. Okay, so we're gonna go one by one. So the first one would be connecting with DHT sensor. Okay, so we're going to call the library dht.h, and after that we're going to declare the variable that's given in the library and assign it a variable called DHT. From this we would be inheriting all the functions of the DHT library. Okay, so the setup is the part where we'll be writing all the initial states. Okay, setup only runs once in a lifetime until the controller is not resetted. So the serial.begin tells the microcontroller on how much data rate it should communicate. So which is usually called the baud rate, which is number of bits per second. So 115200. So this is what I give. We can give there a certain set of ranges. We can choose any of those. I'm choosing 11,005. I mean, sorry, 1,15,200. Okay. So after that, we're going to set up the pin, which is DHT dot setup. Okay, and since we're using the D4 pin, we're gonna type D4. Okay, so after that we're gonna just, I think, yeah, we're done with the setup over here. There's nothing else to do. Now we're gonna add a small delay just to see how the values are coming, or else it will be very fast. Now we're gonna declare float humidity, okay, equals to DHT dot get humidity. Okay, we have to check the spellings. I haven't installed any kind of auto completers. We have to check each and every spelling. Temperature, Similarly, DHT dot get temperate, temperature. Okay, once we do this both, we're gonna get the humidity and temperature. But at any cases, like if you have connected to the wrong pin or the sensor is not working, we have to write something so that we know the sensor is not working. For that purpose, we're gonna use an if loop and check whether the values which we are getting are numbers or not. Is NaN is not a number. Okay, so whenever we get in these variables humidity and temperatures, we get Na or any kind of variable which are not numbers. Okay, the DHT sensor is in such a way, the library is in such a way that if the data is not accurate, it is either gonna give us an Na or N and something like that, but not numbers. So every time we're gonna check whether the humidity and temperature are actually numbers. Okay, so is NaN means is not a number. Whenever is NaN is true, then means the value which we are getting is not a number. Or it's not like humidity and temperature, like either of one if them are wrong, then we are having an issue. Okay, so that's the reason I have using the or function, or not or function or operator. Okay, is NaN temperature. Okay, so we have to make sure that if this function runs, the code should not execute after this. So we're going to print something, serial dot print ln. Okay, we will just type failed to read sensor, and after that, this is the crucial step, return. So what's going to happen if either humidity or temperature is not a number and we are getting some kind of another data? So we're going to break the loop. So the return is going to make sure that the program would not execute after this. The return is going to send it back to the loop. Okay, as we know, setup only runs once and the loop runs for the infinite number of times. Okay, so in case like if everything is fine, like it is working, then we are just gonna print it for the time being, serial dot print. Okay, humidity double dot enter, and serial dot println. Okay, humidity, I'm just gonna copy them. Okay, and after that we're gonna just copy this and temperature over here, temperature over here. We're just gonna give a small space. So yeah, one more thing, the temperature is in degrees centigrade. Okay, if you want to change them in Fahrenheit, you can do that as well. Float FAHRENHEIT Fahrenheit equals to DHT dot to the same thing, Fahrenheit. I hope spellings are right. Fahrenheit, and then we're gonna pass the temperature to this. So this will convert the temperature to Fahrenheit. Okay. So I'm gonna print it. I'm just telling you. So here we're just gonna comment this out. Okay. So I'm gonna just check the spelling, FAHRENHEIT Fahrenheit. Okay, good. So yeah, we're done. And after that, we're gonna connect my board now. We have connected the board. It's available in comp5, and now we're gonna upload the code. So nothing, no errors, everything works fine. D4 pin. So everything is fine. Let's just wait for a few seconds. I think we're done. We're almost done. And we're done. Okay. No, we're not yet done. Here we have to have done uploading. Okay. And one more thing is that these are like the default settings that I have already left it out like that. So if you're using something different other than NodeMCU, or there are many other versions, so like if you're changing the baud rate or anything, you can just do it in these settings. I'm leaving them as default. Okay. Even in this, if it's your first time, there may be a chance that you would get something like this COM4 and something. You have to click on that. You have to type NodeMCU, select the NodeMCU board and click on OK. In that case, like at that point only, the NodeMCU you will be having something like this. Okay, before that it will be just COM serial port, something like that in most cases. Okay, yeah. So we have done. Let's just open the serial monitor and see whether we're getting it or not. Yes, we're getting it. Humidity 24, temperature 28. Sorry, humidity 14, temperature 28. Then again, this is in degrees centigrade. So right now I'm going to disconnect the DHT sensor and show you that this specific function also, I mean this specific loop also works. So I'm disconnecting it from the D4 pin. Fail to read sensor. Okay, now I'm going to reconnect it. Okay, now I have reconnected. So you can see the temperature is coming. Okay, so now we're done with this step. So the next step would be adding the Wi-Fi support. Okay. Okay, let's move to the second step. So the second step would be adding the Wi-Fi support. Okay, so now we're going to tell the NodeMCU to which data point, access point it should connect. Okay, since NodeMCU has the Wi-Fi capabilities. So for this, we're going to use a library called ESP8266 Wi-Fi.h. So if you have added the NodeMCU packages, then you would be having this library automatically. If you haven't done that, just check like how to add the NodeMCU packages in the internet. You'll be having a lot of tutorials. Just follow this and you'll be knowing like how to add those packages. Okay, so let's get into the coding part. So we're gonna just go hash include again ESP8266 Wi-Fi. F should be capital dot h. Okay, we have added the library. Now we're gonna give the Wi-Fi credentials. So here we're gonna give const char access ID equals to, I'll soon give my access point, and then const char password equals to your password. Okay, and after that we're gonna just give it a small delay, a very small negligible delay. Okay, just to make sure that we have given the D4 pin setup pin. Like the D4 setup will take some time, but giving this delay would make sure that the setup has completely been done. Okay, then we're gonna type serial dot println connecting to Wi-Fi, just so that we can know that we have reached the point of connecting to Wi-Fi. Okay, so then we're gonna give Wi-Fi dot mode. So this tells that the Wi-Fi is acting just as a client but not as a server. Okay, STA. It's not really mandatory, but yeah, you can give that, not an issue. Wi-Fi, because we're not going to add any kind of server type of codes in there. It's just going to act as a client, send the data to those MQTT server. So it's not really necessary, but yeah, giving it won't be any harm. Then we're going to type Wi-Fi.begin. So here we're going to tell like to which SSID and password access point you should connect. And here we will be giving the SSID, comma, and then the password. Okay, so now we have to make sure that the Wi-Fi is connected. Okay, so for that we're gonna block, like the access point doesn't really come, I mean it won't connect immediately, it's gonna take some time. But the microcontrollers, they run so fast that they're gonna skip the part, but they won't check whether the connection has been successful or not. So for that reason we're gonna block the controller's function, the NodeMCU functions, until the Wi-Fi access point is connected, until the NodeMCU is connected to the Wi-Fi point. So for that we're gonna check the status Wi-Fi dot status. Okay, so whenever the Wi-Fi is connected, we're gonna get status as WL underscore connected. Okay, you can just print this if you want. So since we're using a while loop, as long as the Wi-Fi status does not become WL connected, this will be keep on rotating. Okay, so just to show that, we'll give it a delay of half a second. Okay, and then we're gonna print serial dot print dot. So this will tell, like it will just give a small dot 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 dot, like we will be understanding that there's something going on, that's loading, a loading effect to be more precise. So then we're gonna just say println Wi-Fi content once this loop is exited. So that means we have successfully connected to our Wi-Fi. Okay, so we're done, I guess. So yeah, so this is pretty much for the Wi-Fi setup. Like we're not gonna do anything in the loop. Okay, the loop part is mostly for the PubSub client only. Now that we have done that, so I'm gonna give my access points over here. I've already copied that. You won't be able to see it since they are mine. Okay, now let's just reconnect the board. Okay, the board's connected. Yep, we are connected, and upload. Let's see if there are any mistakes. We have a small mistake. What is that? While was not declared. This code. While was not declared. Oh, I have given capital W. Yeah, my bad. I should have checked the color. It's gonna take some time. Okay, we are done with uploading. Let's just open our serial monitor. I'm gonna reset it once so that you guys can see the connection. So you can see dot 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 Wi-Fi connected. And from that point, we're gonna get the humidity and temperatures. Okay, so we're done with the second step as well. Now the third and the final step is adding the PubSub client and then we're going to use the library pub/sub client and then send the data to the MQTT server. Okay, that would be the final step. Let's do that now. So yeah, now we have reached the final step, that is on how to communicate with the MQTT server. For this purpose, we're going to use a library called pub/sub client. By default, this library is available in your library set. In case you don't have it, then all you got to do is go to Sketch, include libraries, manage libraries, and just search pub/sub client. You'll be getting mostly on the top result. You have to install this one. Okay, I have already done that. So let's just go into the final step. So for this, we're going to type hash include, okay, pub sub client dot h. Okay, so we have included the library. And one more thing, from the beginning of this tutorial, I've been saying these things as variables. I'm sorry, these are not variables, these are classes. Okay, and this one is the object. It is showing error, but basically this is the object. So now let's define the servers. Okay, we're going to define the server, the port, the topics. Okay, so let's const char star server. So this would be the server, MQTT server. Okay, and after that, const int port, the port which we need to connect, and finally the topics, const char star. So I'm gonna just say humidity underscore topic equals to, we can give any name here. So I am giving EFS / humidity. Any string works here. Okay, we're going to do the same for temperature. TEMPERATURE, temperature topic. The similar name, temperature. Okay, so we have given that, and after that we're gonna use the Wi-Fi class of the pub/sub client. So we're gonna, that is the Wi-Fi client, and then assign it an object called client. Okay, and then we have pub/sub client, another class, client and object, and then pass the ESP client object. Okay, so what's this gonna do is, it's gonna tell that all the functions of the Wi-Fi will be now available to the client. Okay, so if you are familiar with the OOPS concept, you will be knowing that. So after that, we have done this setup. So after that, we're gonna tell client dot, okay, set server. Okay, like in this function tells which server it needs to connect. For that, we're gonna give server comma port. Okay, so which server are we going to use? We're going to use a free MQTT server that's available for us. So I would be using HiveMQ. Okay, the HiveMQ public broker. We're just going to open this one. We're going to just go view public broker, and we're going to click on connect. Then you'll be having this broker.hivemq. This is the host. We will be giving it in the place of server. Okay, and you must have noticed the TCP port, which is 1883. We're gonna give it over here. I have declared it as sent. Okay, we have given that. So now client.server is available, server port we have, I'm sorry, client.set server has been done. This will try to connect with that client now, with the server now, sorry. So after that, we're going to check if our client is connected or not. Okay, because it's a very crucial step. As I've told you, microcontrollers and microcontrollers like the NodeMCU, this one runs at a very fast pace, but the internet handshake and other kind of like the handshake and the process usually takes some time, so the connection may not happen immediately. For that purpose, we have to check whether the client is connected or not. So in this case, we're going to check this specific function dot connected. So what this gives us is that whenever the client is connected, it gives us true. And if the client is not connected, it gives us false. Okay. So for that purpose, whenever this client dot connected is false, I'll make sure that I try to, kind of reconnect. Like I'm going to check whether it's connected or not. Okay. For that, we're going to create a small function called reconnect. And we're going to call that over here. So this is the case when we are not yet connected with the server. Okay. Then client dot loop. So what does this do? So it makes sure that since we are using MQTT, it is a kind of a WebSocket. So it needs a regular interval of handshake. So the client dot loop makes sure the connection is always alive. Okay. Now we're going to implement this reconnect function. So in the reconnect function, we're going to first check. We'll write a while condition, while loop, while client dot connected. As long as this is false, we have to make sure that it is in the while loop itself. Okay, we're gonna just give something like we are trying to attempt for the connection, trying to connect to server. Okay, and after that we're gonna force it to connect client dot connect, and we're going to pass some random ID. It's not necessary that it should be accurate. Since we're connecting to a open broker, it's not necessary that client ID should be accurate. It could be anything unless it is your own server. So we can just say EFS humidity and temp. Okay, so this is a client.connect. It just requires ID. It's not necessarily need to be any accurate, or we're not going to use it anywhere. Okay, then we're going to just say serial.println connected. Okay, so if that client.connect is true, then we're going to print connected. Okay, in case it's not, so we have to know what went wrong. So we're gonna print serial.println. We'll just say print, in this case, error, and then finally we're gonna print ln client dot state. So the state gives us all the errors, like what is the present state. In that state we'll be having the reasons like is it a like is like the Wi-Fi is connected but you do not have internet in that, like the port error or anything like that. In this state you'll be having all of that information. Okay, so we're gonna just give a small delay. I'll be giving it 5000. Okay, 5 seconds. So 5000 in this sense, 5000 milliseconds, which translates to 5 seconds. Okay, we're done with the delay part as well. So after that, we are done with the client dot loop. We are done with looping. Like we have given most of the stuff for the MQT server to connect. Now the second step, the final step, would be, I'm gonna remove this. Just comment that. We'll be sending this data to the MQTT server after we are connected. Okay, so for that, what we're going to do, the first thing, we're going to use client dot publish. Okay, and then we're going to give first the topic name. Okay, so what is a topic? Humidity topic. So we're going to give that first. Okay, and then we have to give the value which we need to send, but this publish function accepts only strings. For that purpose, we're going to use a function, an inbuilt function D2strf, okay, which converts floats into strings. So the first variable will be the float which we want to convert. In this case, it's humidity. Okay, and then the minimum width, like it should have at least this number of elements. So I'm going to give it as 2. Since this is a float, it should be it would be having decimal point, so I'm rounding up to 2 decimal point precision. And finally, the variable that needs, like the variable that it will be stored. So I'm going to declare those variables now. Char temp. So I'm just going to call it temp, and then I'm going to give it a width of 8, and then same for humid. Okay, now I'm gonna call temp over here. Sorry, humid, not temp. Humid over here, and finally I'm gonna call the temperature over here, and then humid over here. Now in this topic, we're gonna send DEMP. Sorry, this kind of confusing. HUMID, humid, and then again we're gonna publish. Where is this one? Temperature, right? Temperature topic. And then temp, and temp. Okay, so yeah, we're done with the coding part. So let's just go through everything. So this part connects the server and the port, which is broker.HiveMQ, which port 1883. Then we're gonna see whether we are connected or not. If we are not connected, we'll be calling the reconnect function, which will try to connect to the MQTT server again and again. So once it's connected, this while loop will be executed. Sorry, while will be exited, and after that we're gonna publish it. Okay, let's upload this code now. I'm connecting my NodeMCU. Okay, so I'm gonna take this and put it in N just to see whether we're getting the data or not. Okay, so we're done. I'm gonna compile the sketch and let's see if we get any errors. Yes, we're not getting any errors. Okay, cool. So meanwhile, while this happens, just to check how like if data is getting published and is whether it's received by the HiveMQ server or not, we can go to a broker, I mean a client of HiveMQ client. This one, MQTT website client. HiveMQ has given us that. So we're gonna just use the same in data over here. Only the port, we're not gonna use it. Okay, and click on connect. So we are connected. So now let's go into this one. reset pin. Yeah, we're done. Let's just open the serial monitor. Yeah, we're getting the temperature, means the data is being published. Let's just reset so that you can see everything. Wi-Fi connected, trying to connect to the server. We are connected to the server. Humidity and sim. Now we're going to take these topics, EFs dot humidity. Let's go with temperature first. EFS temperature. And now we're going to subscribe to these topics. All we got to do is skip. What's going on here? Paste, subscribe. You can see here, right? 27, 27, 27, 27. Okay. So we have successfully sent this data from our NodeMCU server to a MQTT server. Okay. Sorry, NodeMCU module to MQTT server. So the next part to be adding our own mobile app so that we can read this data. For the mobile app, we'll be building it from scratch and we'll be using Flutter for that. Okay, let's do that. As we are now done with the hardware part, now let's move on to the software part. So since we are sending the DHT sensor data to the MQTT server, we will be requiring something like an app to see the data. Okay, so for that, we're going to build a Flutter app. So for that, we want to be use a library called MQTT client. Okay, so we're going to install this library by using any of these three methods I have installed by using the dependencies. So all you got to do is go to MQTT client. You go to the PubSec YAML and paste this specific line over there. Okay, so after that, you're going to just do the pub-get and the packages will be automatically installed. Okay, and along with that, you have to go to Android app src build.gradle. Sorry, not this one. Manifest. You have to go to the app manifest, which is here somewhere. Main profile, I think we have to go to the main and you have to paste these two lines. Okay, so these two lines will give the app access to internet. This one's not mandatory, this one's mandatory, but this one's optional. You can give on or skip it, that's up to you. Okay, now since we're done with this parts, let's just move to the coding. So here we're gonna implement the MQTT client. Okay, so first we're gonna just create a variable final client equals to MQTT server client. Okay, so client identifier can be left as empty since we are using a free server, so we won't be having any client identifier. And here we're going to give the server name, which is broker.hivemq.com. So the advantage is that once I have called this specific class, automatically the library has been imported. You can see it over here. Okay, and there isn't much for us to do over here. We have to write a specific function to call, to connect, and to fetch the data. Since we are publishing the data in the NodeMCU, when coming to Flutter, we have to subscribe it. Okay, but both are clients to the MQTT server. So let's just create two variables. So yeah, since mostly we will be receiving a string from the PubSub client, from the MQTT server. So I'm just declaring them as string. Temperature equals to 0, just to show the initial value. Along with that, comma, humid is also equals to 0 in the format of strings. Okay, temperature, I think spelling mistake. Yep, temperature. Yeah, we're done with this part. And now, so here we're gonna write a small function. Okay, so that it connects with the MQTT server, but it has to happen in the init state. Okay, for that reason, we're gonna just write the init state. And then again, you can do it in many other ways. So we have many state management libraries like Riverpod. We have providers and consumers. You can create a service and put the service class, like you can create a service class and put call them in the service class itself. But for the, I mean, for minimalistic purpose, like to maintain as much less as code possible and to decrease the complexity, we're gonna just call it as function. Okay, so here we're gonna define the function. We're gonna call it MQTT client future, since it will take some data and it will be take some data to process. So we're gonna just add, we will be returning a type future type of int. So we're gonna just set up MQTT client. Okay, so this is gonna be a function that we are going to call. What happened? And here we have to return 0, just a value of int can be, because it's of type future int. Okay, that makes sense because we have given it as int, so it's most probably gonna be a future int. Okay, let's just do one thing for the time being. Let's just give it as int. Later we can change it as future. Set up MQTT client. I can just copy this and place it in the init state. Okay, so now let's do some styling. So in the material app itself, you can just kind of remove this banner over here. I'm going to just minimize this so you can see it clearly. So we can remove this banner by giving debug check mode banner as false. Okay, and after that we'll be just removing all of this part, and we're gonna give a container. Okay, and we'll be giving width. We will be using the media query, not like this, media query dot of context dot size dot width. So it's gonna take the width of the current screen, like the mobile screen. Okay, then height, media query, same thing over here. Copy and paste. We're gonna just remove and give it as height. Okay, and after that we want everything to be at the center of the screen. I'm not gonna give any app bar. If you want, you can give. For my design purpose, I'm not giving any app bar. So alignment dot center. Okay, now everything's gonna be centered. So along with that, we're gonna give a background color. So color 0xFF212121. So it's kind of a light gray and black mixing. If I just hot reload it, you will be able to see it. Yeah, you can see this, right? So it gives a very aesthetic look. So I'm just using that. You can use whatever you want. And after that, we're going to just create a child column, and we're going to go to children and text. I'm just going to say temperature. Okay, and then we're gonna add the values. I like dollar temperature. So this is a string interpolation. You can just read it somewhere on the online. Centigrade. So we can use some something like this to produce a degree symbol. Okay, we can use these unique codes to produce the degree symbol. It could be degree centigrade, right? So capital C. Okay, so let's give some space, and after that let's give some style, font size, sorry, text style, font size around, so let's say 20 px 20. Okay, that's more than enough for the time being. Control C, Control V, and after that the same goes for humidity. Okay, it will be humid, same variable. Here we don't be requiring this one. Okay, we're gonna remove this, we're gonna save, and we're just gonna do a hot reload. Let's just give the color white. Oh, sorry, colors dot colors dot white. The same thing goes for here as well. And now we're going to do a hot reload. See, right, so since they're on the top, let's just bring them in the center. Main axis alignment, main axis alignment dot center. This will make it center horizontally, sorry, vertically, and the cross axis alignment will make it center horizontally. Okay, we got that. So let's give this percentage, right? Percentage would be much accurate for this. Okay, we're gonna style it. It will style this one much more after we have written this function completely. Okay, now let's just go back to this one. So set up MQTT client. This is gonna be a bit longer version. We have to write a lot of code here. So the first one would be taking the client and specifying the different ways we want this library to behave. So the first one will be client dot logging, which we're gonna turn off by setting it as false. So if we turn it on, like, we will be get the logs of what's actually happening behind the scenes, which I don't think is required for this part. And then we're going to set the protocol. This is a very important one. So as you can see, we have two protocols. This is version 3.1 and the other one is version 3.1.1. Since we are using broker.HiveMQ, we are using HiveMQ, so we'll be using version 3.1.1 because that's what they are built on. Okay, and after that, client dot keep alive period. So we're gonna just give it an integer. So this states that the client will be active for at least 20 seconds, and after that it can disconnect. And after that we have the client dot connect timeout, connection timeout period. So this is this time, like, so if there is a connection timeout, after how much specific time it can, it can think that connection has timed out. To be more precise, it's something like, so up to 2 seconds it will try to after every 2 seconds it will try to reconnect. Okay, after that we have to write some functions. The first one is client dot on disconnected. So we have to tell, like, which function should be called when the clients get disconnected. Okay, so I will just simply print client disconnected. Okay, and after that we're going to call the second function, which is obviously client dot on connected. Okay, so this functions will trigger whenever the specific conditions happen. Okay, so print connected. Okay, so after that it will be the main function, which is the connection and message. So I'm going to just say final on connection message. So this is the main part. So here we'll be declaring a function. Along with that, we'll be calling a sub. We'll be declaring a we'll be calling a class, and along with it, we'll be calling it sub functions. So the class is MQTT connect message. This one. Okay. So as you can see, this is a class of MQTT connect message, and we're gonna now inherit each of these functions. So what this does is it is gonna allow, like, we're gonna define protocols. Along with that, we're gonna define what is the quality of service and what would be the topic which we have, which we need to call whenever there is an whenever a client is disconnected without any specific reason. If a client get disconnected, it will be calling a specific topic. Okay, we'll be seeing on that. So the first one will be dot with client identifier. If you remember, we have given an identifier in our NodeMCU code as well. Similarly, every client requires an identifier. It should be unique. It doesn't need to match with anything. So I'm just gonna give some random thing like 1 2 3 4 5 6 ESP, not ESP. I'll just give EFS. I'm pretty sure somebody will use ESP. I'm gonna just give EFS, and after that, dot with will topic. So this one, whenever a client disconnects, okay, so this topic will be called, like a message will be sent to this topic. So I'm just gonna say, I'll just call it about topic. Okay, and after that, okay, my bad, it should not happen here. And after that, again, we're gonna have another dot function, dot with will message. Okay, so this will be the message that will be sent, like client disconnected unexpectedly. Oh my god, I'm typing too fast and I'm doing a lot of typos. Client disconnected unexpectedly. Okay, and finally, dot, not finally, we still have one more thing, start clean. So we are not expecting any kind of callbacks, or we're not gonna expecting any kind of feedback. So we're gonna tell the server to start clean every time. Like, there are some acknowledgements that will be listed in the queue, so we're just telling it to ignore it. We're not gonna call them back. So that's what start cleans means. And then finally, we're gonna define with will QoS. So we have QoS 0, QoS 1, and QoS 2. So each one I have told you like what is QoS 1, 0, and 1 at the beginning. So here we will be using at least once, which is QoS 1, MQTT QoS dot. You can see here that at least one, mostly once, exactly once. So at least once is QoS 0, sorry, 1. So we are going to be using that. So this will make sure the like there is, I mean, the data has been sent at least one. I mean, it will be expecting an acknowledgement just for once. Okay, converse. So after that, once we're done with all of this, then we can just print that we are connecting. we'll just say HiveMQ connecting. Okay, and after that we're gonna call our client dot, okay, connection message equals con mess. So now we are passing the connection message to the con message to the client dot connection message, so that the client can publish, like it can connect, like it can connect and publish as messages. Okay, so now we're going to write a try catch over here and on as well. So most probably socket exception is one of the thing. We can just write catch e. We're just gonna print it. That's it. Nothing much. Here, when coming to here, we're gonna write await, okay, client dot connect. Await will not work since we have removed the future. Okay, let's give future of void for the time being. Why are we still not getting? Okay, I think we have forgot to write async as well. Yeah. Okay, so since we have given as void, there is no need of any returns. So now our client.connect will connect our app to the MQTT server. And after that, if by any chance we have any kind of errors like a socket exception, we're gonna make sure that we disconnect the client dot disconnect. Yep, client dot disconnect. Like we can have multiple errors, so I'm just for the assuming that we will be having the socket exception. And after that, we're gonna check the status. If client dot connection status, if you remember, we did something similar in the NodeMCU. We're gonna do it over here as well. MQTT connection state dot connected. So we're gonna check whether we are connected or not. And if we are connected, we're gonna just say HiveMQ connected. Else we're gonna say something went wrong. Okay, along with that, we're gonna make sure we're gonna disconnect and exit. Okay, so what it is gonna do, it's something like a return. So if the client, it gets disconnected, and we're gonna exit this function, making sure that it does not go to this part of the function. Okay, after that, we're gonna give the topics. Const topic. So I'll just call it as TM because this would be the temperature topic. So what was that yesterday? Yes, EFS patient temperature. So this will be the topics that we are going to subscribe. Const hum equals to EFS humidity. Okay, so after that, there is only one thing left to do, and that is subscribe. Client dot subscribe. subscribe. Okay, and along with that we're gonna give topic, which is temp and the QoS level. So I'm gonna give the QoS level as once, dot at least once. So don't get confused. This is QoS 0. So this one is for this topic and message, and this one is for this topic. Okay, there's a difference. And along with that, we're gonna give humidity. So I'm just gonna make it 2, mostly once, at most once, just in case, because this is a free broker server, we cannot be sure that we're gonna get data every single time. Okay. So now since we have subscribed, now the part would be we have subscribed it, and now we have to make sure that we listen to the data which we are getting, and for that we'll be using client dot updates. This is for listening. Dot listen. Okay, so we'll be getting a data of, what do we say, a list, to be more precise, a list of MQTT received messages, okay, of type MQTT message. This is what we're gonna get. So we're gonna just say as something like C, and after that we're gonna just give this one. So final, what's happening over here? It's somewhere. Okay, my bad. Okay, just a small thing. We have to write this as a function. So this is the function that will be receiving everything. In this we have to write the code. So here we're gonna get a final, we're gonna call it message equals to, so there's a passing that's required. So C, we're gonna get an array of data of 0. We're gonna take the first one. In that we'll be getting getting a JSON data that we are going to pass now. So first, an array of JSON data. So we're going to take the first one, okay, C of 0 dot, we're going to call the key payload, okay, as MQTT. So we are just converting the type, that's it. MQTT publish message. We're gonna convert it to the type of MQTT publish message. This is typecasting. So then we have final, which is like we're gonna extract the data. So let's call it data equals to MQTT publish payload. So we're getting the payload, okay, dot byte2 string. Byte2 string as string. Yeah, this one. We need to use this one. I'm pretty sure you already got what this does. So now we're gonna just pass the message dot payload dot message. Now this will pass the data and give us the exact message that we are publishing through the NodeMCU, that is the temperature and the humidity. Okay, so since we're getting two different values, we're going to just write a small logic to make sure that we get what we wanted. So that would be if, okay, C of 0, similarly dot topic, we can just keep this one just in case, is equal to 10. Okay, then we're gonna update the value temp, that's what we said, right? Temp, yeah, okay, temperature, I just got confused. Temperature is equal to data. Okay, so we're going to do the same. We cannot write an else because it's a free server and we can have multiple topics. Somebody may just use our way of writing topics, so that could be an issue. So that's the reason I'm writing an other if loop. And did I write humid over there instead of humidity? Okay, I wrote humidity. Okay, we got the data. And finally, just to make sure, we will just print both of this. Print temp, not like this. Temperature, humid, and then just in case we're gonna print data as well. Okay, we're done. We're gonna destroy the entire thing and making sure that we don't get any kind of errors. Did we call this? Yes, we did call that. And let's just open the terminal. No, not here. We're gonna open. Yeah, we're connected to the HiveMQ. Just rerun it. HiveMQ connected. Now I'm gonna connect my NodeMCU as well. I'm gonna switch on the NodeMCU. Just in case, let's just open our code. We can open the NodeMCU code right now. I think I've made a mistake on the names of the topic. ESP humidity. Yeah, I gave it as ESP temperature and humidity. We can just copy these topics and just paste them in here. ESP temperature, ESP humidity. Yep, we're getting the data right now. We're getting the data. You can see it over here. Now, since we're getting the data, now we have to, like, as you know that the state in a Flutter doesn't get updated until we write something for that. For this purpose, I'm just going to use a callback function and write, I'm going to use set state and callback functions to update the states, but you can use any kind of state management libraries. But not to make this more complex, I'm just going to use a simple set states. That's it. Okay. So for this purpose, I think I will be writing a callback function over here in this. It will be something like this. Function. Okay, it's going to accept two string parameters. String, Okay, and along, so we're gonna call this something f, we're going to call it sender. Okay, since it's sending the data, I'm just gonna call it sender. Okay, in this we're gonna just have something similar. Before that, we're just gonna make sure the sender is getting what it needs to get. So here in the end, I'm gonna say sender temperature, comma, humid. Since we'll be having some kind of default value, so once we get the temperature topic, the temperature and the previous humidity value will be sent, and the state will be updated. Okay, I'm saying a lot of OKs recently. Yeah, oh my. So after that, we're gonna just go over here. We're gonna do the same thing. We're gonna just write string T, which is temperature, and string H, which is humidity. What's wrong? What is this saying? We have to come complete this. Yep. Okay, and after that, set state temperature is equals to T, and after that humid is equals to H. With this, I'm sure we're gonna get the data. Just restarting the app. Let's see what happens. Yeah, we got the data. Humidity is 43.35%. What's wrong? You just check your Arduino. I think the sensor went somewhere high. Okay, what's going on? Why am I getting humidity 15, 15, 15? So, okay, so I have found the issue. So it seems like somebody is also using the topic ESP and temperature. So after adding an extra line of EFS over there, I have started getting the temperature and humidity values accurately. Okay, so with this, we have completely transferred the data. Like we are now able to fetch the data of MQTT server, which is sent by the NodeMCU. We can even style it a bit so that it looks good. So I'm gonna do that now. For that purpose, I have already written a sensory cards code. So you can see it over here. It's a sensory card code. And in that, we'll be calling them something like this. So we're gonna just paste them over here and change this to temperature, and we'll just change this to humid. We're gonna just refresh, so it will look something like this. Okay, so I hope you like this video. Make sure if you have any kind of doubts you can leave. And one more thing, I would be adding a link to my GitHub where you'll be having all of these codes with comments explaining each and every line. You can just directly go to it. And one more thing is that I won't be giving you the entire setup of this Flutter project. I'll only be giving this part of the code in a single page. That's it. Okay, so you can find the link in the comment section or in the description as well. Thank you for watching.